Okay, thanks, David. So as David said, my name's Charles. I've been with the University of Miami Library since 2015. Before that, I was at Cal State Sacramento since '06, and I've worked both in IT and library IT in various roles during that time. And so I discovered Python4Lib via Code4Lib, and I think Dave's done a great job in kind of bringing us together and sharing what we've learned and so forth. And so that's why I wanted to contribute. What I want to present today is an introduction into Flask, MongoDB, and Docker. And so I want to explore how each of these roles of these technologies plays and the benefits they offer. So briefly, Flask is a Python web framework known for its simplicity and versatility. It excels at building web applications of all sizes, from basic IPs to intricate user interfaces. A core advantage of Flask is its modular nature. So we can start with a simple foundation and introduce features incrementally as needed. Next, we'll integrate MongoDB. That's a NoSQL database, and unlike traditional relational databases that require predefined data structures, MongoDB offers greater flexibility, and it allows us to accommodate new data types or modifications to existing data without extensive restructuring. And then finally, we'll go over Docker. That's what we use to create our development environment. And Docker provides a method for packaging our entire application, including Flask code and the Mongo database, into a common standardized unit known as a container. And this approach eliminates the common frustrations of encountering discrepancies when applications between different environments. Basically, it works on my machine, works on my computer problem for developers. So throughout the presentation, we'll look at specific benefits, and I'll try to highlight some best practices. And we'll look at some of the benefits of the stack, including rapid development, data model flexibility, consistent and portable applications, and scalability. So hopefully by the conclusion of the presentation, you'll have a solid understanding of the basics of Flask, Mongo, and Docker, and why it has some benefits. So I'm going to share my screen. Okay, so as I was telling David earlier, I went back and forth on whether or not to do a live coding versus a show and tell. And the reason I chose to go with show and tell is because the live coding, well, inevitably, something goes pear-shaped. And then we spend a lot of time with me just like saying, I don't understand why this is not working. And then two, I don't think we would get far enough. So the way I structured this presentation is I created a project and I put it in GitHub, and at every stage of development, I tagged it. So you'll be able to use this GitHub repo, and you'll notice here, if you go to tags, I have version 1, 2, 3, 4, 5, and 5.1. So if I'm not sure if you're aware, but let's say we go to version 1. What you can do, just a quick tip, is right-click and duplicate this tab, and you can switch github.com to github.dev, and it'll give you an IDE, and you can look at the code. So this is basically loading an online version of VS Code. So you can either use Git repo, the Git, to pull the repo and then check out various tags if you want to go ahead and explore this after this is over. And again, you'll be able to see what the code looks like at specific points in time. And then as well, apologize for the size of the text. I tried changing it right before we started, but it doesn't really change that well. But here in the left, in the code project structure, I've created some docs for you. So I've created a list of common commands for Docker and MongoDB and Flask and Git, and then also added an explanation for how they're used, what they do. And then as well, for the more complicated sections, I created a document that lists that version, the instructions for that version. So we have version 4, and you can go through and see what the code should look like and how to create that code at that point in time. And the same for version 5, where it gets a little more complex. And then and then we're also going to go through Docker and Docker Compose. So over here on the left, we have the structure. If you're familiar with Flask at all, you can see that it's broken up. This is a pretty standard Flask project structure where you have an app. I have books, and we'll go into this later in the presentation, but this is a module. And then you have your templates. I've provided some basic JSON data for you to use in the application. And then you have the Docker file and the requirements. This is the requirements that are needed for the libraries that are involved. And then I created a small little utility to create a secret key for the application. And so before I begin, let me put in chat a bunch of links, and hopefully this will distract you from what I'm saying and all the mistakes that I'm bound to make. So this is everything that I've used. This is also included in the repo, so I'll go through them briefly. So we're going to use Docker. So this is where you would download Docker and Docker Compose. This is Docker for desktop. We're going to be going through Flask. This is the documentation for that. I'm going to briefly go over Compass, which is a MongoDB GUI. So this is it here. This is so you can easily add data. See it's basically a GUI for your database. I also showed how to implement Bootstrap, so you can have a basic UI before you start doing any customization to the look and feel. We're going to be using Mongo 7.0. One of the best practices, I'm not sure if you're not familiar with Docker, it's based on tags. And if you see something where it's like Mongo : latest, you never really want to use latest, because for best practices, you never know when that's going to be updated and how it's going to break your code. So you always want to tag your code. As well, this is the package library for Python. And then I included this. It's always a great best practice. As soon as you create a project and you're going to put it in GitHub, you want to create templates for git ignore, so that you don't include stuff that you don't need, and you definitely don't want to version, especially when it comes to secrets and so forth, and environment variables and the like. And so I'm not sure if you're aware, but GitHub's gotten a lot better at scanning code bases, and if it finds secrets, it shuts down your repo. So this site allows you to create templates. So you can do Flask, Python, and you just create it. And let me do it again. it'll create a get ignore for you for all of the various the ones you need. So if we look at the one I've created, I've ignored Flask, Python, my particular IDE, which is JetBrains, and VS Code. And so that keeps, it's quite a long file, but it keeps all the stuff that shouldn't be shared or versioned, to ignore. And then Docker also has an ignore file, and I've included that. So those are just some, quick best practices. So let me show you the project that we're going to, that this repo, if you clone this and create, will ultimately create. So the point of the presentation is not really the end product of the project. The project is very simple. It's a CRUD to add books. So, just add, edit, delete. And the real point is to describe how you can use Docker Compose to create a development environment for your Flask and Mongo application. So ultimately, this is what will be created, and it's just a simple CRUD application where you can add books, edit books, and delete them. And you can see here I have an index, and I've also added debug information. And so I've left that in there on purpose so you can see, you can look at the code and look at how to, add debug information when you're trying to fix something. So the first thing I want to go through is the Docker Compose file. So Docker Compose is an orchestrator for services. And so you can see here we have services, web, and Mongo. So without going into too much into the history of development, if you had a local machine, you would have, a local instance of Mongo, and maybe you had a Mac Python. But as soon as you try to package that up, or first of all, you couldn't package it up, but you wanted to share your code, your Flask code with your colleague, it would have problems because their machines are not going to be the same. So along came Docker, and Docker creates containers that ultimately become images that can be shared, and the code base is the same regardless of the environment, whether it be on a local machine, a VM, or in the cloud. So I created this file, and then I also created this markdown file that explains each one of these lines. And here again, you can see we have services, and it allows us to define multiple interconnected services that work together that run our application. And here, context, we have build, right? And so build is just a command. It's going to build what you tell it to. So in this case, we're telling it we want it to build this Docker file, and we want the application to be exposed to port 5000. And then volumes allows you to have persistent data during the development cycle. So we'll be able to, our database will live even if you turn the container off or bring the container down. There are different flags you can add to Docker where you can completely destroy something. You can erase all the volumes, all of the container images and everything, but we're not going to go into that. What you have here is the ability to bring your Docker Compose up and bring it back down. And if you come back to it next week, you can bring it back up and your data is going to be there. And so here it's telling you that it's the data from your app is going to be copied into a directory called app. This defines your environment file, your .env. This is where we have the Flask secret key. This secret key was created using this little script that I wrote for you. And .env is never in, you never version this. So this, you can tell on my IDE, it's gray. That means that it's not being versioned. And this will be called as a config variable within the app, and we'll see that soon. So this also, so it depends on Mongo. That's the connector between the web service and the MongoDB service. And then here, Mongo image. So this, instead of having a build where we're saying build something locally, so this is our local directory here, Docker file. This is saying pull the official image from Docker Hub, which we saw earlier. And then MongoDB operates on the port 27017. And then volumes, this is where the database data is stored. And then this ultimately brings them together. So you can see here, it's running. If I were to do Docker compose down, and you might notice that I have DCU and DCD. That's because I use all my G's and I use aliases. You know, as a developer, I'm inherently lazy. I'm always trying to find ways to do something faster, more efficient. So instead of typing Docker compose down, Docker compose up all the time, I just made aliases. But for sake here, we'll do Docker compose up and down. So Docker compose down. So you can see our containers here. So it's removed a Flask MongoDB web container. That's this service here. And our Mongo container, which is this one. And then our network, which is this here. So now if we go here and we go to local 5000, this is going to be down. Now, if we want to go back up, there are two different ways that you can bring a Docker file or Docker container up. You can do Docker compose up, or you can do Docker compose up with a flag D, and D detaches it so that you can use your terminal. But right now we want to see all of the debug information here. So we're just going to do Docker compose up. And the first time you do it, you want to do the flag build, but you can do build anytime you want. It's just a little slower. So when we do that, you can see here that it's pulling. We can go back. It's loading all of the various files. It's pulling from different locations, and we'll go through this. This is our Docker file pulling the Python environment. And so we use Python 3.11 Slim. You can see that it's defined a working directory. It's copied our requirements. It's run pip install and the requirements file. And then it copies all of that stuff over into the layers and ultimately the container and the images. So I'm sure you're a little familiar with Python, of course, it's Python4Lib. So you're familiar with pip and all of that. Our Docker file does all of that stuff for us. And then so here you can see that it's created our network. It's created our Mongo container and our web container. And this lets us know that it's using a .env. Here's our development address. And this is just debug information. So every time we do something, we're going to get some debug. So now if we go back over to we can see that our app is loaded. And every time I click something, we see something in our debug. And another benefit of having the volumes is that when you add something new to the code base, it'll be reflected live. Now, that's not true for environment variables and other config type of stuff because that has to be loaded again. But for code changes, it's true as a live reload. So the next thing we want to look at is the Docker file itself. And so let me open up over here. So again, I've tried to the best I can without, being too complicated, is to explain what this file does. And there's very few lines here. It says 10 lines, but there's still spaces. So, but it's extremely powerful. So we're defining our Python image. And again, you notice I didn't use latest. And I also used a flavor called Slim. Another best practice is you want to use the smallest image possible. A, it makes it faster, to load and everything else. But B, it makes a smaller surface area for attack vectors. So there's less, there are basically less ways for, someone evil to try to break your app. So the next thing is you define your working directory, and your working directory is the directory inside of the container where all of the code is going to live. The next thing we're going to do is copy our Docker requirements.txt. So again, I'm sure you're familiar with a requirements file. Here we're using Flask, PyMongo, and Flask WTF, which is for forms. I got all of these versions from the Python package library. These are the latest versions as of like last week or so. And again, you'll notice I define the version specifically, and you could just put Flask, PyMongo, and Flask WTF, but that always leads to problems down the road. The next thing is copy dot to dot. So copy everything into the Docker container, this Docker container. That's what this dot stands for. So this is why it's important for your Docker ignore, right? The Docker ignore will keep things that you don't want copied into this app out of the app. So it's, again, it's very important to have git ignore and Docker ignore. And then finally, it has a command to run Python, and then we have it run a file called run.py. So if we look at that file, I'm sure this looks familiar to you. It's loading the main module and telling the app to run, given it, in our case, we want to debug and the host that it's attached to. So you'll notice that we also have app equals create app. So is it this one? Here we go. This is under app init.py. This is where basically all the bootstrapping takes place. So I've created a function that defines our secret key. And here you can see it's pulling it from the config file, which is the .env, and it's given it a fallback. This should be better, but I just wanted it to be explicit as to what's going on here. Here we have CSRF protection. This is for the forms. This is to protect your apps from cross-site scripting, extremely important. I've been doing this for many years, and I say this all the time, but it's still true. If you look at the top 10 exploits in code, it's all, no matter how long security preaches, it's still SQL injections and cross-site scripting. Those are always in the top 5, if not the top 2 or 3. So it's extremely important to security is paramount in today's environment. So here we're defining our MongoDB client, and this is the port that we defined earlier in our Docker Compose. Here we're again just defining the DB for the app, and we're going to import our module as a blueprint. I described what a blueprint is in one of the instructions here. Let's see, is it this one? No. Here it is. So blueprints make Flask code modular, and it's extremely important to keep your code modular, because when you first start, like if you see a Hello World tutorial, you're going to do everything in the main.py file. And before you know it, after the first couple of hours, your py file, your main.py is going to be well over 300 lines. And you're going to just start mixing everything in there, and that's a bad practice. You should always try to keep your files under 300 lines. And that's just another best practice that I've picked up over time. And you want to make your functions as atomized as possible. Now, this app that we've created, it's not perfect, but it tries to demonstrate some of those principles. But in Flask, they have what's called a blueprint, and it's a way to organize related routes, codes, static files. So in short, it's a way to create a module. And over here at the left, in the project structure, you'll see books where I have init, forms, modules, and routes. When you look at the code in GitHub through the various tags that I created, you'll notice that my main.py started. So here, it starts simple enough, right? So we have, let's see if we can make this bigger. Yeah. This is your basic Flask hello world. It creates a route, an index route, returns something simple. So we don't even have templates at this point, and declares the module. So if we go on to version 2, let's see where I'll duplicate this. You can see I've already gotten this file much larger, right? I've defined 3 different routes, books count, and again, I'm just returning JSON from the database. But you can imagine, again, this is just very, very, very simple, and we're already at 26 lines, and we're mixing something main, which should be a relatively small file, with something that should be its own module, books. So if we go on to version 3, I wonder if there's a quicker way for me to go through this, but I'm sorry. So at version 3, I think I can't remember. I'll have to look and see what I did. But ultimately, let me go to, let's see, can we do it here? Yeah, let's do it here. Five is ultimately where we modularize stuff. So now if we look at main, now we're up to 83 lines to do the edit, add, and delete, and do an index. So what I wanted to demonstrate here is, as you're coding, yes, you can build, start building your app in small baby steps, do it in the main.py, but ultimately you want to modularize this code. And so if we get to 5, let me click on something else because this file is going to go away. So you'll notice I no longer have main.py. I have init, which defines the app and then starts bringing in the modules. And this is where you have the idea of blueprint. So if you look at our books, now we have a module here. We define our blueprint. We bring everything in from routes. If we look at routes, this is that code that we looked at earlier to add, edit, and delete. And so here we have index. This creates our list of books. This is our add function. This is our edit function. And this is our delete function. So we've went from something very simple to something more complex that can now be expanded upon, and it can become more robust. So instead of, books, let's say we wanted to add a module for resizing images. We could do that. We would follow the same pattern as we have here. If we wanted to add another module for scanning PDFs and using Python to do something to the PDF, we could do that. So again, you want to modularize and then bring your code into the main init file and keep that nice and small. And it's much more organized and a lot easier to read. So we can look at the README, and actually the README it's easier to see here. So I've done as well as I could to try to describe my environment, the repo, the steps to clone it, what you need to do to bring everything up, how to add some initial data, and then some development practices. So here again, you can see we're using Python4.11, Mongo 7, Flask 3, PyMongo 4.7. I developed on a Mac Studio with a M1 Max. Just as a quick aside, the image that we used, so if we look at it, here you'll see this tag, multi-platform. So when Apple introduced the M1 chip, that changed basically everybody's development environment. So if I were to develop on an old Mac compared to an M1, my Docker Compose would not necessarily work if the image is not set for multi-platform. If it's not, there are special commands that you can add to your Docker Compose to account for that. I have to do that in a PHP app that I have. I'm not going to go off into too much of a tangent, but just be aware that while Docker Compose, it is it does encapsulate, but there are still caveats. And so the image that I chose is the multi-platform one because I have a M1 Max. And then I listed my OS, the ID I used and the Docker version that I have. So go back. If you're not familiar with Git, I went through how to clone the repo. There are free clients out there as well. There's SourceTree. There's one for Mac. I think it's like Git Mac or Mac Git. I'm not sure, but I use Git Kraken. But the point is, you can either use terminal or a GUI. I recommend learning Git initially. That way you know what's going on. You should always version your code. And one thing our team has started to implement, and I'll show you briefly, is the idea of it's not an official protocol yet, but it's becoming a standard called Git conventional commits. And so when you make a commit, you usually give it some kind of message. And up until a couple of years ago, they were unstructured. You would just write something like, working on Mongo or something. So Git conventional kind of gives it a format. And so you can look here at mine and you can see where I've got FET, that stands for feature, with a colon, and then what it does. So there are various prefixes that you can give it: feature, fix, refactor, docs, chore. There's other ones I can't think of off the top of my head. But so this makes it easier to share your code and your colleagues to know what you're doing. And then when you look at it, you break up the commits too, with a decent explanation. So a Git commit has the commit message, which is the subject. Then you give it a description, and then it has an optional footer that you can give it with further detail, and then you can go one step further if you want. And if you were fixing an issue, let's say we had issue number 32, you could say refs 32, and it would link to that issue. So that's just a way to deal with your, to better organize your GitHub. So we've looked at how to bring up the code in Docker Compose and the Docker file. The next thing I want to look at is MongoDB. MongoDB is the thing that I think might cause the most problems when it comes to first bringing this up and troubleshooting and stuff. So I've created a troubleshooting guide for you that tells you once your container is up and running, how to go through and see what containers are running, how to connect to a container, how to insert some test data, some simple commands. One of the reasons I chose to do this demonstration with Mongo instead of MySQL is the Mongo commands for inserting and pulling data and stuff are so much more simple than learning MySQL or SQL. So if you're not familiar with writing SQL statements and stuff, and all you're trying to do is come up with a simple application that you want to, develop an idea from without, setting up a massive development environment, that it's easier to go with Mongo if it's going to be a DB connected application. And that's why I've went with that. But this troubleshooting guide should help you through if you have any problems connecting. I had a problem connecting because on my local machine, I have an instance of Mongo in my Mac, and it was running at the same time. And, I should have thought of that, but I didn't. Took me a little bit. Then I'm like, okay, let me pull up my containers, see what's running. And you can go to the terminal, see what's running. And so let's just do that, for example. So here you can see that I'm running. This is the MongoDB container that's running. When I had the one running on my Mac as well, it was listed as well. So my GUI, my MongoDB Compass, was confused and didn't know what to connect to. So no matter how many times I tried to add data, it would fail. And so let me show you, how to add some test data. There are two ways. Like I said, I included the JSON. Let's see, we'll delete this one here. So first, let's go to our app and we'll see that we have George Orwell. And we'll delete that. And it's gone. Now, so like I said, we want to set up our database so that we have some test data. We can do add data, insert document. And let me go to my data that we have here. So let's grab this. So this is a properly formed JSON document, but you don't want to grab the brackets here. You just want to grab the keys and the values. So we'll copy paste that. We'll go here and you'll notice it already has this predefined. What you want to do is click into the dialog box, add a comma, enter, and then add the entry. So now this is going to give it an ID and add this information. So if we insert it, so now we have it, it's showing here in our GUI. And if we go back, here it is. So, and I think we've looked at I'm not going to go too much into this functionality because it's self-explanatory, but so that's how, so this gives you, this MongoDB Compass gives you a nice interface to import data. You can also import via JSON, which is why I added this books JSON. And there's plenty of places, let's say you have, you want to work with an API and it's producing some JSON that you have access to. You can, for quick development, you can easily copy that file, give it a JSON extension, and then import it into your database. And then now you have something to work with. So again, it's about speed of development, being able to get to doing the actual coding and not having to spend a lot of time with your setup and your Mongo. So we're getting close to the end of the time here. The final thing I want to show is I put a document, pros and cons of using MongoDB, pros and cons of using Mongo over MySQL. They're both great. I use MySQL probably predominantly because I deal with structured data. But as you know, in the library, there's lots of unstructured data. And so NoSQL databases, because of their flexibility and the way you can add fields without, a lot of effort, makes it really great for unstructured data. That has some cons as well, and you can look at those in here, and read about those. It'll lead, you can have stale columns and so forth. So, you don't want it to be a free-for-all, but again, MongoDB works really well with unstructured data, which in the library world, we see a lot. So finally, I have the templates here. The templates are, they're called Jinja. I have I created a base. So I talked about integrating Bootstrap. To integrate Bootstrap quickly, you can use a CDN where you just add the CSS and the JS. Now you have Bootstrap. They have a lot of boilerplate code that you can grab and create, navigation bars, grids, layouts, you name it, cards. One thing I want to point out here is in our home, you can see where it extends the base. So base has our overall document, and then everything that we add that extends it pulls in that information. So we have here, so for example, our books, you just start with extends, and then you add your, the template that's directly related to your books. Here we have a form template. I did want to go through one more thing, sorry. So this is our form. This is how simple it is to do forms with Python and Flask. This is defining my form. If I had to do this in PHP, it would be, I don't know, at least 100 lines, probably 10 times as much as this. And then this is models.py. And so let me go down here a little bit. I explained this in one of the documents as well in the CRUD, but you'll see here from DIC to dictionary. This converts the data back and forth so it can be inserted into the database. One of the, again, the great things about Mongo and Flask, this makes it look so simple. Like you're defining your model and you're being able to convert this data back and forth. In a lot of systems, you have to have what's called an ORM, where you're laying over an entire application or library over your code of database just to be able to communicate to the database to do the data conversion. So again, this is a great Flask feature where you can get something up and running really quick and be able to get the database to communicate with the code, insert, edit, and delete. And again, you see we just have a few lines of code rather than this massive framework. Like when, if you're using PHP, you're going to have something like Laravel and Symfony with Doctrine and with a front end. So you just have a massive code base. Here I've got this up and running, and I did it in a few hours. So I'm sure there's some things here that I've forgotten, but I know we're running close out of time, and I wanted to leave just a few minutes for questions. That's my presentation. You're more than welcome to contact me in either via my email or through Slack, and I'd be happy to answer any question that you have. Thank you.
Awesome. Thanks so much. Yeah, definitely some good chat in the comments going on as well. I would just mirror one that Michael mentioned, that this was a really great talk or resource, and we'll need to spend some quality time with the repo when we have the chance. Likewise, I'm gonna probably pick through it and just kind of build up version by version. And what I really liked is how you kind of emphasized like the documentation and just a lot of the good coding practices that are underlying all of this as well. So thank you so much for that. There was kind of one conversation I wanted to bring to your attention as well regarding using Django versus Flask. Do you use both? Do you put a lot of thought into one or the other, or what's your take on that?
Yeah, I have used both. Django's a little more robust, and I think it's more for a larger enterprise application. I know a lot of what we do in the library environment, you just don't need all the overhead, right? You don't need all of the extras. And Flask allows you, it has just about everything that Django has, but you can get up and running so much faster.
Mhm. Thanks. And I think a couple people mentioned that as well. So cool. Trying to get through any of the other chat. And if anyone else has questions, feel free to unmute and ask away. I think a couple people shared your pain with the M1, M2, and Intel Mac chip conversion. Oh, and the conventional commits was another thing. That's fairly new to me. I've generally just been putting, my own little comments in for myself, but seems great to have a structured way to do that.
Yeah, let me add that to the, here we go. I'll add that to this chat, and I'll update the repo and add that to the list of links.
Mm-hmm. Cool. And I was also thinking the modular approach that you mentioned is also just such a good practice, especially if you want to, redeploy certain functions across other apps or, whatever. Such a good approach. And I like the idea of, keep it to 300 lines or less. Maybe even less than that, depending on what you're working on.
Yes. It just makes for maintainability, going 3 weeks from now, you're like, oh, why? And then you're trying to go through all of that. So
yeah.
I have a suggestion. I don't know, Charles. That would be a great sequel if you could show us how to deploy this kind of application in the cloud. I'm assuming, depending on the cloud, that may look somewhat different, but I still don't have, I cannot visualize how this is actually deployed on a server somewhere.
Well, so I work with Azure. We do have some VMs, but our department has tried to go towards Azure cloud environments. And so we deploy to what's called Azure Web App for containers. And so Azure has its own method for dealing with Docker containers. And so in this case, you wouldn't use Mongo. You would have to use Azure's database, which is called, I think, I want to say Compass. It doesn't matter what it's called right now, but anyway, it's a NoSQL database. You would have to connect to it and deploy the Flask app to the container. Eddie's on here. He's my colleague here. We've deployed, I don't know, 4 or 5 different Flask apps to Azure, and so I can demonstrate that. But again, depending on how your library IT is structured, I don't even know if you would have access to it. It's a pretty high level discussion. I don't mind going over it. I just don't know how much benefit it would be to the larger group, because in most instances, your your campus IT department is going to be the one to handle that. Now, I can show you how to develop for that, so that you could, if you needed to hand it off to your ID department so they could deploy it, we could do that. But going through the whole, deploying to Azure, again, I don't mind doing it, but I don't know how valuable it would be.
I think yeah, you're right. I mean, may differ depending on the cloud your institution is using. But yeah, like configuring Docker itself and how, because I'm assuming the database will be a separate image somehow, and your application talking to the database is something that you configure. I think that's more actually relevant than what kind of service you should be using to get a particular type of database you're interested. Yeah, like that's the difficult part, I think, configuring your development in such a way that the later it can be deployed. The technicalities, how this happens, is maybe less relevant.
No, you're exactly right. When Eddie and I first deployed an application, a Python Flask application to Azure a few years ago, it was definitely a learning curve. And while Docker for development is great, there are other considerations that you have to take into consideration to get it to be production ready. And I'd be happy to share that. I mean, I think that's totally relevant, and we have working examples of real life in production applications that are developed locally using our Docker Compose, and then we have a staging environment and a production environment that create the Docker containers that ultimately get pushed to Azure, that have the configuration that's necessary for it to be able to run in a production environment.
Just making a note that might be a future presentation. But I'll try to give you a break before calling on you again to do another presentation. So cool. Are there any other questions? Well, cool. We are just about at the bottom of the hour, so I guess we can wrap it up there. Thank you so much again, Charles, for the presentation. This was fantastic. So I'll work on getting the recording. I will definitely link it into Slack, and eventually, hopefully, hosted somewhere on YouTube maybe. So, all right. Thanks so much, everyone. And yeah, have a great couple of weeks, I guess.
Thanks for the opportunity.
Mhm.